Good day, my name is Timothy Adekunle. I am here to discuss about how to obtain the mean and variance of normal distribution. A continuous random variable x is said to have a normal distribution if its probability density function is f of s equal to 1 divided by sigma root 2 pi exponential raised to power negative 1 divided by 2 into the bracket x minus mu divided by sigma all square, zero otherwise. Now, to obtain the mean of normal distribution, expected value of x is equal to integral negative infinity to infinity x multiplied by f of s dx, and our f of s is equal to 1 divided by sigma square root of 2 pi exponential raised to power negative 1 over 2 into the bracket x minus mu divided by sigma all square dx. By factorize 1 divided by sigma square root 2 pi out of the equation, we have 1 divided by sigma root 2 pi integral from negative infinity to infinity x exponential raised to power negative 1 divided by 2 into the bracket x minus mu divided by sigma close bracket all square. So we now say that let z equal to x minus mu divided by sigma and a equal to mu while b equal to sigma. So therefore our z equal to x minus a divided by b. By cross multiply, we have zb equal to x minus a. So therefore our x equal to zb plus a. The x now equal to zb. Now the expected value of x now equal to 1 divided by b square root of 2 pi integral from negative infinity to infinity into the bracket zb plus a exponential raised to power negative 1 over 2 z square bd z. That is, we represent any place we see x, we put zb plus a there, and any place we see x minus a divided by b all square, we put z square there. So by opening the bracket, we have 1 divided by square root of 2 pi, that is our b here, cancel b there. So we have 1 divided by square root of 2 pi integral from negative infinity to infinity zb exponential raised to power negative 1 divided by 2 z square dx plus 1 divided by square root of 2 pi integral from negative infinity to infinity a exponential raised to power negative 1 divided by 2 z square dz. By factorize b out of the equation, we have an a out of equation, we have b divided by square root of 2 pi integral negative infinity to infinity z exponential raised to power negative 1 divided by 2 z square dx plus a divided by square root of 2 pi integral from negative infinity to infinity exponential raised to power negative 1 divided by 2 z square dz. By standard normal distribution, we know that our integral from negative infinity to infinity exponential raised to power negative 1 divided by 2 z square dx equal to square root of 2 pi. And when we integrate integral from negative infinity to infinity z exponential raised to power negative 1 divided by 2 z square dx, we have this one, and we put the limit there, we have is 0, and this one square root of 2 pi cancel square root of 2 pi, we have a. So therefore our expected value of normal distribution by proving give us a, and our a equal to mu. So the expected value of normal distribution is equal to mu. To obtain the variance of normal distribution, we need to obtain expected value of x square. So our expected value of x square is now giving us integral from negative infinity to infinity x square f of x dx, and our f of s equal to 1 divided by sigma root 2 pi exponential raised to power negative 1 divided by 2 into bracket x minus mu divided by sigma all square dx. So factorize 1 divided by sigma root 2 pi out of the equation, and we get equation 3. Same thing, we represent x minus mu divided by sigma by z, and a equal to mu, b equal to sigma also here. After that, in this equation, you just substitute the value of each. Value of s is b, z plus a, and the value of z there is x minus mu divided by sigma square. So in equation 3a, we open this bracket with this square, and the result is b square z square plus 2abc plus 2 plus a square. So by using 1 divided by 2 pi to open the bracket, we obtain this equation. And so therefore, we need to integrate each of these equations one after the other. That is exactly what we want to do now. The first part of the equation before, which is b squared divided by root 2 pi integral from negative infinity to positive infinity z squared exponential raised to power negative 1 divided by 2 is z squared dx. We say let u equal to z and integral v equal to integral z exponential raised to power negative 1 divided by 2 z squared. So our dv now equal to negative exponential raised to power negative 1 divided by 2 z squared, and our du here equal to 1. So using integral by parts, and the formula of integral by part equal to integral u dv equal to uv minus integral v du. Using integral by parts for the first time, we obtain this result. So we can see that we can still use integral by part for this aspect also. Just take this one out and put the limit there. Use integral by parts for this part of the equation again, we obtain this result. And after that, we need to integrate our integral from negative infinity to infinity exponential raised to power negative 1 divided by 2 z squared dx. And when we integrate it, we have square root 2 pi. We need to put, and this we need to put our limit there because there is no integral again. And after we put our limit there, you know that this one will give us 0, and this also will give us 0. By putting our limit there, it will remain just only negative 2 pi. Using this negative to open the bracket, we have this positive. And we can say that this one cancel this one. So we have the result of the first part of the equation b squared. And in the second part of the equation we are considering, which is this one, when we integrate this integral from negative infinity to infinity, we obtain negative exponential raised to power negative 1 divided by 2 z squared. And by putting our limit into this equation, we can see that it will give us negative 1 plus 1, which give us a 0 at the end. And the third part of the equation we are considering, which is this one, by integrating it, we have this result. And we can see that root 2 pi can cancel root 2 pi. The third part gives us a square. So expected value of x squared now giving us b squared plus 0 plus a squared, which is equal to b squared plus a squared. So to get our variance of normal distribution, we have variance of x equal to expected value of x squared minus expected value of x all squared. And expected value of x squared equal to b squared plus a squared. And expected value of x squared equal to a. So we need to square it. By this time we square it, we have b squared plus a squared minus a squared plus a squared minus a squared cancel each other, and we have b squared. We know that our b equal to variance. By square it, we have sigma square. So therefore, the variance of normal distribution by proving gave us variance square. Thank you for watching. See you next time. Please don't forget to subscribe.